Just kidding. I'm not actually going to do that. Don't worry. Especially you, Caesar. I know how much you love that voice. But no, not doing the voice. So, today we are talking about the Pythagorean Theorem, which happens to be geometry's most elegant theorem. This is 9.4. No English accent. Not going to happen. Okay, our objective. Use the Pythagorean Theorem and its converse. Pretty simple, which is the beauty of this theorem. It is so versatile, but I'll go on a little bit with that later. So, Pythagorean Theorem. Okay, it is the most versatile of rules in geometry because it is so simple and it has just a ton of uses. Because if you think about it, if you use the diagonals of any geometric shape, you can create right angles. And the Pythagorean Theorem relates directly to right triangles. So, let's get right into it. Theorem 69. The square of the measure of the hypotenuse of a right triangle is equal to the sum of the squares of the measures of the legs. And this is obviously the Pythagorean Theorem. Okay, so if a triangle is a right triangle, then you will have a squared plus b squared equals c squared. Okay, I'm sure you've heard it before, so this should be nothing new. Okay, now, the converse of the Pythagorean Theorem, this is where it's also useful. It can help you determine if a triangle is a right triangle just by knowing the lengths of its sides. So, Theorem 70 states that if the square of the measure of one side of a triangle equals the sum of the squares of the measures of the other two sides, then the angles opposite the longest side is a right angle. So, if a squared plus b squared does equal c squared, then the triangle is a right triangle. However, if a squared plus b squared is greater than c squared, then the triangle is an acute triangle. And if a squared plus b squared is less than c squared, then the triangle is an obtuse triangle. So again, see how this is really useful in helping you determine so much about the triangles just by having three numbers. And you can figure out quite a bit of information just from those three numbers. So, let's put it into practice. Just jump right in. Okay, solve for x. So, remember, c squared is always going to be the hypotenuse. It's always going to be the longest side of the triangle. So, easy peasy. Just use the Pythagorean Theorem. And we say that 36 plus 64 equals x squared, because that would be 6 squared plus 8 squared equals x squared. I have a feeling that's going to pop up right behind there. Nope, good. Okay, so 100 equals x squared, and we have plus or minus 10 equals x, because we reject that negative 10. So, x equals 10. That's it. So we would get x equals 10. And again, I hate that right on the background. So hold on. There we go. All right. Moving right along. Let's try another practice problem. The perimeter of a rhombus is 60, and one diagonal is 24. Find the other diagonal. All right. So you're probably like, well, how in the heck does that help us with this? Well, remember what I said. Using the diagonals, you create right triangles. So think about it. A rhombus has 4 equal sides, diamond-shaped kind of thing. So what I like to do, because I'm a very visual person, draw the figure. All right, so if the perimeter is 60, what else do we know about rhombus? Well, the 4 sides are equal. And the diagonals bisect each other. So if one diagonal is 24, that means that each half is 12 because it's bisecting. And if the perimeter is 60, then one side's got to be 15 because 60 divided by 4 is 15. So that's how I got that. And 24 divided by 2 is how I got that, because there's 2 pieces here, 4 sides there. So I've got a right triangle here, and I only need to find x. So again, use the Pythagorean Theorem. So we've got a squared plus b squared equals c squared, which we can replace, a squared and b squared with 12 and 15. 12 squared is 144, 15 squared is 225. Subtract 144 from both sides, and you'll get x squared equals 81. And if you square root that, because remember, you need x, not x squared, you get x equals 9. And I'm just throwing out the negative 9 because, you know, we can't have a negative measurement. So x would be 9, and since 9 is the measure of half of the diagonal, because remember it's bisected, just multiply 9 times 2 to get the total length of the diagonal, which is 18. So your answer would be the diagonal is 18. Okay? And last but not least, this problem seems more difficult than it is. Okay? So, say Lucy skipped 3 meters north, 2 meters east, 4 meters north, 13 meters east, and 1 meter north. How far is she from where she started? Well, she started right here, and she finished right there. So, we can use the Pythagorean Theorem to determine what the length is from here to here by creating a right triangle. Now, how the heck are you going to create a right triangle? Well, you know 2 of the sides. Whether or not you realize it or not, you do. Let me superimpose a triangle on here and show you. See? So, if I added up these sides, going up, or north only if you want, 3 plus 4 is 7, plus that last one, that gives me 8. And then the 2 plus the 13 gives me 15. See where I'm going? And I just need to find the hypotenuse now. So, we take 8 squared plus 15 squared and set it equal to x squared. So, which gives you 64 plus 225 equals x squared, which is 289. Yes, there is a square root of 289. So we square root both sides. So you get x equals plus or minus 17. Again, reject the negative 17. And you get x equals 17 meters. So, you've had a few really good examples of how you can use the Pythagorean Theorem in word problems, and just regular old problems trying to find parts of triangles. So, you have a good idea as to how it's going to be used. You have a good idea as to the type of questions that are going to be from this section on the test. Hint, hint. A lot of these were based off of those. So, keep that in mind when you're taking your notes. Okay? I would actually write down the wording, especially for the last 2. So again, it's not as long as a unit as I thought it was going to be, but still there's a lot of important stuff in here, so make sure you're taking really, really good notes. And that is it. Look forward to your next videos next week, and hopefully the lack of actual written out proofs is something that you've enjoyed this week.